This is part of a series of videos around generating multiple solutions during the improve phase of a domain-based project. And in this specific video, we're going to take a look at tools in the lean thinking framework that can help with solution idea generation. The specific learning objectives are to identify and provide overview context for many of the common lean thinking concepts or methodologies that can help teams with idea and solution generation early in the improve phase of a domain project. We'll also explore in greater detail a specific lean thinking tool that I like to use regardless of if it's a manufacturing, production, or service and human facing process. It's called mistake proofing or Poka-Yoke. So we'll take a look at some specific examples with Lean Thinking's Poka-Yoke. All right, I've cleaned up my screen a little bit and I'm pulling information from the Business Process Improvement Workbook right now. And what I've got in the background is our domain summary sheet and the list of tools and activities that are commonly performed in a domain style project. And I'm zooming in on the analyze and improve phases because where we're at right now is we've finished the analyze phase and we've got a number of root causes that were determined. Our job now in the improve phase is to first identify a broad list of solutions. Later on, we'll narrow those solutions down. And for each of these root causes, I will for sure do some brainstorming on each one to come up with a broad list. But I find that brainstorming alone isn't usually enough, or how do I rephrase that? Brainstorming is effective, but it has limitations. I've got a great little article on the course materials website that talks about some of the limitations that brainstorming has. I always start with brainstorming, but I typically also want to have my teams explore the use of other tools to create the broad list. And one of the other tools is to think about for each root cause, are there any lean thinking concepts that could either reduce or eliminate this root cause? And we'll add those additional solutions to the list. I'm hoping that these lean thinking concepts will add these additional solutions to the list. And there are a variety of concepts and methodologies common to what we consider lean thinking principles that can really help. Let's take a look at some of the more common ones. So below I've got a list of common lean thinking concepts and methodologies, and I don't mean in any means for this video to try to be an exhaustive, insightful analysis of each. And I don't for my teams either. For each one of the root causes, I've got brainstorm solutions for each root cause. I'll then ask the team, let's take a look at these common lean thinking concepts and see if any of them fit with the particular root cause that we're trying to generate solutions around. And if so, I'll send team members off to do further research. And each one of these topics are covered in much greater detail in our green and black belt curriculums. Heck, we've got, in some cases, multi-day programs just dedicated to each one of these topics. But let me give you a quick summary of each. It's the same quick summary I give my team members, and then I send them off if the topic seems appropriate to do a little further research on some possible solution examples. If I'm in a production or manufacturing environment and it involves preventative maintenance or other types of scheduled maintenance activities, there's a lean thinking concept called total productive maintenance that has a whole suite of tools and step-by-step approaches around those maintenance activities. That's one area to consider. If the workplace that we've observed is disorganized and we would benefit from workplace organization, the approach is called 5S. It's a 5-step methodology, and its mantra is a place for everything and everything in its place. If I know that I've got disorganization that a particular root cause is associated with, I'll have team members research 5S. If I'm looking for ways to manage inventory better, where I've either got too much or too little, not enough on hand, a visual inventory management technique is called Kanbans. The best example of a Kanban system in a non-manufacturing environment that I can give is I'm guessing that for most of you, the way that you manage sugar in the kitchen is handled through a two-bin Kanban system in which you have a big inventory supply that is your bag of sugar, your 5 or 10 pound bag of sugar. But you don't have that setting out on the countertop. You have a much smaller bin containing the sugar that you have on hand for immediate use, whether it's a little sugar shaker or it's the little quart jar of covered sugar. That's an example of a two-bin Kanban system where you've got one bin at the point of use location and a bigger bin that you're pulling from. But Kanbans are an effective way for inventory management. Quick changeovers. This is in environments, especially production environments, where at the beginning of the process, you have to set up the system. You have to set up the saw jigs and you have to set up the printing and all of the ink that flows through that, or the plastic extruder, or you have teardowns at the end where you have to tear the equipment down to get ready for a new setup procedure for the next type of product request. The technique to speed that up is called single minute exchange of dies, or SMED. And I always use the example of NASCAR. NASCAR has spent the last 75 years doing quick changeover improvements to cut down the pit crew times when that car rolls in from minutes to seconds. That's an example of SMED. If you're looking at problems that involve bottlenecks or long wait times, sometimes it's about throughput improvements and throughput management. And there's a whole body of knowledge called single piece flow, or a quest to get to single piece flow through the system. It's about managing your batch sizes better. I'll send people off to do a little bit of research on that. But one lean thinking concept that I will almost always have teams consider, because I find that it's useful for both production as well as service environments, is mistake proofing. We'll take a look at any of the root causes and say, is it appropriate to consider ways to make it impossible for that root cause to be triggered, to mistake proof the system? If so, the lean thinking approach towards mistake proofing, it's called Poka-Yoke. And so let's take a little deeper dive into Poka-Yoke and how it can be a powerful technique both in production and service environments. So frequently, I'll bring my teams into the room, and after we've done brainstorming and come up with some solutions, I'll list out each of the root causes. And then I'll ask the team, great possible solutions. Now let's take a look at ways that we could prevent each one of these root causes from happening altogether, or ways that if the root cause were triggered, its impact on overall performance or its effects on customers and process workers would be dramatically reduced. It's a concept we call mistake proofing. I always give a couple of examples so the teams kind of can get a sense of where we're going with this. I'm going to use my family as an example. In our household, we have a commuter car that is a little VW diesel Beetle. Gets great gas mileage and can zip me back and forth to work pretty easily. My wife, on the other hand, drives a Honda mid-sized SUV vehicle. It takes unleaded fuel. If I were to pour diesel fuel into my wife's Honda unleaded vehicle, really bad things would happen. But in the 5 years that I've had this diesel vehicle, I've never once made that mistake. And it's not because I took a online course on better fuel pouring techniques. It's because my diesel nozzle will not fit into my wife's unleaded fuel tank hole. That's an example of a mistake-proof system. We did a Kaizen event on campus in which we were running into problems where highly educated undergraduate and graduate students were throwing the plastic containers that held all of their cafeteria foodstuffs. They were throwing it into the trash with the compostable trash that was also being tossed in. That costs the organization thousands of dollars. So in future state, one of the solutions we came up with was to make sure that the trash bin hole was smaller than the tray itself. There's another example of mistake proofing the system. Now, in both cases, these were using physical jigs or physical devices to help prevent the error from happening. But I think your biggest gains with mistake proofing are often in IT systems. For years, I would send messages without the attachment, not because I was trying to confuse the system, but because I would forget about it. And I would say, take a look at this attachment, and I'd forget to include the attachment. And now my email system, when I do that, it pops up a little reminder saying, hey, dummy, there is no attachment here. Make sure that you put an attachment in. Data validation for IT and service-based systems, I think, is one of the biggest ways we can take a look at mistake proofing, whether it's to make sure that the data was entered is not too big or too small, or that indeed there was data placed into a particular field that it was needed. Data validation, great mistake proofing way. When we are doing mistake proofing, there is a systematic technique. And in your workbook, we cover more details on this, but it includes things like for the triggered event, can we think about elimination of that activity? Or what about replacement, different parts to be used? Or what about preventative or prevention techniques? Are there facilitation techniques that can be done before the process activities occur? Are there detection tools that can warn individuals that they're about to trigger a mistake from happening? Or mitigation techniques where you can't prevent the mistake from happening, but you can reduce its impact on performance or safety. A classic example for mitigation is you can't necessarily prevent cars from crashing into each other, but you can put airbags into the cars, and you can put those collision detection radar techniques warning people that you're getting too close to particular devices. Mitigation techniques. Mistake proofing, it's a powerful technique that I like to do for all of the root causes that we've got. It's not a replacement to brainstorming, it's an addition to. And in other videos, we'll take a look at other techniques other than lean thinking concepts to add to the possible solutions that you come up with. The goal right now is to create this big list of possible solutions. And then from that big list, we'll narrow it down to the most importance that will be included in the final implementation plan. More videos follow on ways to create the broad list, and then separate videos on how to narrow that list down to the final most impactful solutions.